Welcome to this online revision session for AQA FP2. We're going to cover the January 2010 question 3 on roots of polynomials. So in this question we have 3 parts to the question. Firstly, we're given a cubic equation and we're given one of the roots. And notice we are told quite clearly here that P and Q, 2 of the coefficients that we do not know, are real, and obviously the other 2 coefficients are also real, which means then that our roots must be conjugate pairs. So, first part of the question then is quite straightforward. It says write down the other root of beta. And using the conjugate pair we'll be able to do that straight away. Then we've got to find the third root and also find the values of P and Q. The key facts which are helpful of course in this type of question are the relationship between the roots, that alpha plus beta plus gamma equals minus B over A, that the pairwise product alpha beta plus beta gamma plus alpha gamma equals C over A, and the product of the roots alpha beta gamma equals minus D over A. So let's get started on this question. Well, A part 1 we said that because of the fact that the coefficients are all real, then the roots are conjugate pairs. So if alpha is equal to 2 plus 2 root 3i, then we know straight away that beta must be equal to 2 minus 2 root 3i. Very straightforward, that first part. And obviously for writing that statement you get 1 mark. Into part 2 we've then got to find the third root. Well, the relationships we knew that we could use here. We can't use the one involving P or Q, so it'll have to be the one that involves D, which is 16, and A, which is 2. And we know therefore that alpha beta gamma equals minus D over A. So that will imply, well, alpha is 2 plus 2 root 3i. Beta, of course, is 2 minus 2 root 3i. Gamma is the root that we don't know, but we know that we've got negative D is 16 and over A, which is 2. Well, what can we do now? Well, we can now multiply the 2 plus 2 root 3i by the 2 minus 2 root 3i. We know a conjugate pair will give you a real answer, so we get 2 times 2 is 4, and then we got 2 root 2 times 2 root 2, which will give us 4 times 3, which is 12, and it's negative times a positive, which is negative. I squared is negative 1, so that becomes overall positive, so that's plus 12 plus the 4, so that makes 16. So 16 gamma equals negative 8. So gamma must be equal to negative 1/2. Okay, 3 marks for that. Well, using the correct method at the beginning here will give us 1 mark here for a method mark. Obtaining the fact that alpha beta is equal to 16 here, that will give us a mark. And then finally an accuracy mark for getting the correct value of gamma here will give us 1 mark. So our 3 marks there for part 2. Hopefully quite easy to obtain. Part 3, we've then got to find the values of P and Q? Well, we know that the sum of the roots, that's alpha plus beta plus gamma, must equal minus b over a, so that becomes minus p over 2. Yeah, because that's my value b and that's my value a. Well, I know that alpha plus beta will be 2 plus 2 root 3i and 2 minus 2 root 3i, so the imaginary parts disappear, so alpha and beta add up to give you an answer of 4. And gamma was a negative 1/2, so this must become 3.5 equals negative p over 2, and so rearranging that will give me, well, 2 times 3.5 is 7, and to make the p positive, that will therefore must become a negative 7. So that's my value of p. Similarly, to get the value of q, what have I got to do? I've got to do the pairwise products, so alpha beta plus beta gamma plus gamma alpha must equal c over a. Alpha beta, we know, was equal to 16 from what we just worked out earlier over here, because it was 2 plus 2 root 3i times 2 minus root 2 root 3i. Then we've got gamma times beta. Well, gamma we know is negative 1/2 and beta is the 2 minus 2 root 3i, so negative 1/2 times that. But of course, if we think about this, here we've got the gamma as a factor in both, and this is therefore just gamma times alpha plus beta. And the reason I've written that is because alpha plus beta was nice and easy, and c over a is going to be q over 2. So substituting again in here, we get the fact that alpha plus beta was equal to 4, because the imaginary parts disappeared. Gamma is negative 1/2, so this is 4 times negative 1/2. So that's negative 2. And this, of course, is q over 2. So 4 times negative 1/2 is negative 2. 16 take away 2 is 14. Double it, and that gives you q as 28. Again, 3 marks for that part. We're going to get 1 mark for using the correct statement, like alpha plus beta plus gamma here for the methods. We then get 1 mark for working through on the getting the p as negative 7, and 1 mark for getting q as 28. Okay. Well, hopefully you found that answer useful. If you want more support for your further maths revision, then please go to the Further Maths Support Programme website.